Thank you for being here today. I am Jessica Rivera. I am here to discuss to you about sampling techniques. What is a population? A population consists of all the elements considered in a study. It is the universe. Gay defines population as the group to which a researcher would like the results to be generalizable. Kerlinger defines a population as all members of any well-defined class of people, events, or objects. So the population can be a group of individuals, objects, events, and organizations. We use populations to draw conclusions. An example of a population would be the entire student body at a school. It would contain all the students who study in that school at the time of data collection. Population also refers to the total number of beings living in a particular area. Population helps us get an estimate of the number of beings and how to act accordingly. For instance, if we know the particular population of a city, we can estimate the number of resources it needs. What are finite and infinite populations? Finite populations are those that can be counted. So finite populations is a collection of objects or individuals that are objects of research that occupy a certain area. Here are the examples. Number 1, all the graduate students at the CEU Graduate School are taking mathematics. Number 2, all the TB patients in Quezon Institute. Number 3, the personnel at the Bureau of Customs in the city of Manila. Other examples are the population of ducks in one cage, the number of a class students, the male population in an environment. Infinite populations are those which cannot be counted. So infinite population refers to the population that cannot be calculated easily because they are unlimited in size. Examples are number 1, the population of stars in space. Number 2, the number of red blood cells in a person's body. Number 3, the cars that cross the Menjola Bridge. Other example is births of insect, as one cannot calculate the birth of insects easily. Here are the factors to be considered in choosing a population. Number 1, objectives of the study. Number 2, availability of data. Number 3, nature of research. Number 4, variables to be measured, assessed, or associated. And number 5, inferences to be made. Objectives of the study. It is logical when a researcher decides to do a piece of research on the attitudes of the public towards the value-added tax. The population to be chosen should be those who will be affected directly. The researchers can get consumers from different parts of the community. Example, a researcher would like to determine the relationship between socioeconomic status and severe diarrhea among adults in a certain barrio in Cebu City. He has to decide on the classification of adults in the barrio and the time of the research. Another example is if a person likewise wants to do a piece of research on drug addicts who have been rehabilitated, then he has to get records from rehabilitation centers and their current addresses. In other words, the objective of the research report determines who the respondents are and the population to which they belong. Availability of data. The data needed for this study must be available. If the population frame does not have the data required for the purpose of the research, then again it cannot be chosen as the population. So, availability of data is used quite frequently. It involves selecting a sample from the population because it is accessible. That is to say, Individuals are selected from the research not because they meet some statistical criterion, but because they are readily available. Nature of the research. The selection of the population is also dependent on the nature or type of research, whether it is historical, descriptive, or experimental. When it is historical research, there is no need for a population. But when the research is descriptive, some studies need populations from which samples may be derived for use. In cohort studies, the investigator may describe the population in terms of the place where they work. Examples: the pediatricians in an obstetrics department. Number 2 example, the salesman in a sales department. So in case control studies where at least 2 groups of respondents are used, the researcher selects 2 population frames. Examples: number 1, those who have a disease and those who do not have it. Number 2 example, those who have coronavirus and those who do not have it. So, in experimental studies, the selection of the population is determined by the variable to be measured or controlled. Example, the relative effects of a certain drug in the reduction of fever. So, in this case, 2 samples are derived from 2 population frames, one the experimental group using the variable and the other group not using the variable or the controlled group. Variables to be measured or controlled. The selection of the population is also constrained by the variables that are to be measured, assessed, or manipulated. Surely, if the population does not have the variable considered for the study, it is not selected. So a control variable is an element that is not changed throughout an experiment because its unchanging state allows the relationship between the other variables being tested to be better understood. Example, temperature is a common type of controlled variable. If a temperature is held constant during an experiment, it is controlled. Other examples of controlled variables could be an amount of light using the same type of glassware, constant humidity, or duration of an experiment. Inferences to be made. The researcher from the beginning has insights into the probable inferences that he would like to contain in his findings. It is generally preferred that findings in a study can result in inferences and generalizations. In this case, a finite population is considered from which a representative sample may be chosen and therefore inferences can be made. Inference is a process whereby a conclusion is drawn without complete certainty, but with some degree of probability relative to the evidence on which it is based. Survey data may be used for description or for analysis. Sample is a part of a population. It refers to persons, events, places, or things used as sources of data. The process of taking a sample is called sampling. So, sample is the small group that you observe, and the population is the larger group about which your generalization is made. According to Ferguson, he defines a sample as any subrogate drawn from the population, or it is a portion of a population. In research, it is usually the practice to take a slice of the big population for several reasons. First reason, it is very expensive to get the entire population. Second, it takes a lot of time to reach what is known as the target population. And third, the sampling enables the researcher to do some inferences or generalizations about the target population. This is a very beautiful experience, knowing about the population from the sample. There are cases, however, when there is no need to get the sampling of the target population. This happens when the contemplated population is small, such as if in your school or company to which you belong, there are only 140 students or personnel. It is wiser to get the entire population because anyway there are only a few members, even if the entire population is big. However, such as in a census, you need the entire population. Padua says that in actual practice, studying the entire population may not be possible because of certain factors such as cost and geographical location of the sampling units. The process, which involves taking a part of the population, making observations on these representative groups, and then generalizing the findings to the bigger population, is termed as sampling. Advantages of sampling. Sampling makes possible the study of a large heterogeneous population. Sampling is for economy. Sampling is for speed. Sampling is for accuracy. Sampling saves the sources of data from being all consumed. There are two kinds of sample. Probability sample is one where all elements of the population frame have an equal chance of being selected. So probability samples are random samples or are representative samples of the population. Findings of researchers using a probability sample can be used to infer the characteristics of the population. Findings are more valid when probability samples are used. Second type of sample is non-probability sample. It is one where not all elements of the population frame have an equal chance of being selected. This sample is not representative of the population. Example, a teacher counted 100 students in the auditorium. She wants to get a random sample of 25 students. She counted the students and said that only those whose numbers are multiples of 4 are included in the sample. The question is this a random sample? The answer is no, because not all elements have an equal chance of being selected, and right from the start, those who were not assigned numbers of multiples of 4 had no more chance of being selected. Here are the types of probability samples. Simple random sampling is the best and most common used probability sampling. According to Ware Sims, he calls it as the best sampling procedure. There are two basic principles in random sampling, which are: first is the equiprobability, which means that every member of the population has an equal chance of being chosen for the sample. Second, independence, which refers to the condition that when one member is selected for the sampling, this should not affect the chances of the other members getting chosen. Table of random numbers. This is considered as the most systematic method for getting sample units at random. When the random sample has been drawn, the sampling fraction is computed with the formula SF equals N over capital letter N. So, where SF is the sampling fraction, small letter n is the sample size, and the capital letter N is the population size. So the table of random numbers contains columns of digits that have been mechanically generated, usually by a computer, to assure a random order. Most books in statistics and research include tables of random numbers. The digits in the random table should equal the digits of your population. A simple random sample is generally used when the characteristics of the population are homogeneous. Systematic sampling with a random start. It is a strategy for selecting the numbers of the sample that allows only chance and the system to determine the membership in the sample. Example, a sample size of 100 is to be drawn from a population of 1,000. So in this case, the sampling fraction is SF equals to a small letter n divide to capital letter N. So that is equals to 100 divide to 1,000, and the answer is 1 over 10. So we got this answer 1 over 10 because we first divide 100 to 1,000, so that is equals 1. And next step, we divide 1,000 to 100, so that is equals 10. So that capital letter N, or the population size, is equals 10, and from it enumerate the elements. So the set of numbers are capital letter N equals to 1, 2, 3, 4, and so on up to 10. So one of the numbers in the set is the capital letter N will be the random start. If from the table of random numbers 2 is the chosen, then 2 is the random start. Then every 10th number, which is the system from multiples of 2, will be the numbers of the participants that will be members of the sample. Stratified random sampling. A stratum is defined as a subpopulation and strata consisting of 2 or more homogeneous populations. The following steps are to be used for the stratified sampling technique. First, construct the population frame with the participants randomly given a number. Number 2, select the number of each stratum using proportional or equal allocation. If the sizes of the strata are almost the same, use equal allocation. If otherwise, use the principle of proportional allocation. That is, determine the proportion of the strata in the population frame and use the same proportion on the sample. For example, if 35% of the population are non-smoking pregnant women, 45% are smoking pregnant women, 15% are non-smoking women, and the other 15% are smoking women, then the same percentage should be found in the sample. You should choose participants of the research within each of the categories according to the sample random sampling methods. Cluster sampling. It occurs when you select the members of your sample in clusters rather than in using separate individuals. It is sampling in which groups, not individuals, are randomly selected. Any interact group of similar characteristics is a cluster. This sampling is sometimes referred to as area sampling because it is frequently applied on a geographical basis. Example, a salesman who markets pharmaceutical products uses different locations of clusters of houses instead of individuals in marketing his product. Another example, a researcher is studying the work experience of nurses uses hospitals instead of individuals and gets a random sample of nurses from each cluster of hospital. So cluster sampling is also used in large-scale survey, while other sampling techniques are concerned only for a few subjects or from few locations. Multi-stage sampling. This is rarely used because of the complexity of its strategy. Moreover, it incurs a lot of effort, time, and expenses. Ultimately, probability sampling is based on probability theory and it focuses on the possibility of events most likely to occur. Kerlinger says that it is likely to be a biased sample. that it is a representative of the population since it uses the probability principle of randomness, and that every element has an equal chance of being selected. Consequently, sampling error can be estimated with a probability sample, it being the difference between the sample value and the population value. Types of non-probability sampling techniques. Non-probability sampling is the opposite of probability sampling, and since it is not random sampling, there is less chance of obtaining a representative sample. Most nursing or medical researchers are involved with non-probability samples. It is also in that strategy that participants of the investigation are not derived through equal chances. Among the non-probability sampling techniques are accidental or convenient sampling and snowballing. Accidental or convenient sampling is a sampling strategy based on the convenience of the researcher. Snowballing is a kind of sampling technique where the population frame cannot be identified. Snowballing, often used when subjects are difficult to identify because they are hidden in the population, like faith healers, transsexual women who have had abortion. Network sampling. It is virtually similar to the process of snowballing in the sense that they have numbers of the populations which are also hard to find and are usually in hiding, such as alcoholic, criminal, rapists, or those who are described as socially devalued. Purposive or deliberate sampling. The researcher selects a particular group or groups based on certain criteria or purposes of variables. Example of purposive or deliberate sampling is when you are interested in finding out the reactions of some people towards the value-added tax. Instead of asking all consumers in Metro Manila whether they agree with this or not, consumer leaders in different locations may be asked about it. This is a sampling with a purpose. Quota sampling. This is oftentimes used for infinite population, and therefore the researcher cannot get a random sample from such big population. Like the purposive sample, this is not a representative sample. Sampling from special population frames. There are also special types of population frames. One of these constitutes patients who are chronically ill, and research ethics not only require informed consent but permissive from the guardians. So example, children who are mentally ill or mentally retarded should require a special considerations from the researcher. Steps in computing the size of the sample determine the size of the study of population. This is easily determined from the scope and delimitation of the study. Decide on the margin of error. As much as possible, the margin of error should not be higher than 5%. Probably 3% is an ideal one. So use this formula. Small letter n equals to capital letter N over 1 plus NE squared. If the sampling is multi-stage or if the population is stratified, compute the sample proportion or the percent by dividing the result in step 3 by the population. Multiply the number of sampling units in each final sampling stratum. Add the samples from all the final sampling strata to find the total sample. Thank you for listening. I hope you have learned something from me. Have a good day.